Hi everyone, this is Dr. Nak. We're going to go over section 2.7, solving absolute value inequalities. Let's just recall what we know about the absolute value. If you remember this, the absolute value of a number is its distance from 0 on the number line. So for instance, if I have negative 3, then negative 3 is 3 units away from 0. So that means that absolute value of negative 3 is going to be 3. Also, just positive 3 is 3 units away from 0. So therefore, absolute value of 3 is going to be 3. So basically, absolute values are always greater than or equal to 0. Okay, so first let's go with the absolute value equations, and please memorize this. It says that for any algebraic expression u and any positive number a, absolute value of u equals to a implies that either u equals to negative a or u equals to a. Let's take a look at an example. So suppose that absolute value of x equals to 7. According to the absolute value equation theorem, this implies that either x is going to be 7 or x is negative 7. So if you want to rewrite this, you can write it as x equals plus or minus 7. Okay, is that true? Because check, if x is positive 7, then absolute value of 7 equals to 7. That makes sense. Now, if x is negative 7, absolute value of negative 7 will also equal to 7. So it makes sense. Okay, so let's call this example A. Now let's take a look at the next one. Let's go with B. Absolute value of x equals to negative 5. What do you think about that? So first of all, absolute value of a number always has to be greater or equal to 0. So in this case, this is telling you that absolute value of x is negative 5. That's impossible. So in this case, our answer is no solution. Okay, now let's go with how to solve an absolute value equation. So step number 1, isolate the absolute value expression either on the left-hand side or on the right-hand side. And step 2, drop that absolute value sign by using the theorem above. And step number 3, solve that equation. And step 4, check your solution. Alright, so let's do some examples. Let's call this one example 2, solve that equation. Alright, so step number 1, what do we have to do? Isolate the absolute value. So how do I do that? Is to subtract 3 from both sides first. So I'm going to minus 3. Then what do we got? 2 times the absolute of x minus 5 equals to 6. Okay, so absolute value is not being isolated yet. So what we need to do is divide this whole thing by 2. Then we're going to have absolute of x minus 5 equals to 3. Okay, now let's recall the theorem. Theorem says that if absolute value of u equals to a, that implies that u is plus or minus a. Okay, so in this case, our u is this x minus 5 now. So this is your u, and this is our a. So let's apply the theorem. So this is going to be step number 2. Drop that absolute value sign by using the theorem. So this implies that dropping that absolute value, we're going to have x minus 5 equals plus or minus a, but a is 3. So x minus 5 equals plus or minus 3. All right, so now I think we can solve for x. So that implies that x is going to be, so I need to add 5 to both. So here what we're going to get is x equals, doesn't matter if you're going to put plus 5 on the front of plus or minus 3 or after. So let me just do it this way. So here you're going to have x is positive 5 and then plus or minus 3. or you can have it as plus or minus 3 plus 5. It'll give you the same exact answer. But anyway, so let me just go with this. So here you're going to have x equals either 5 plus 3 or 5 minus 3. So 5 plus 3 is 8, and then 5 minus 3 is 2. So therefore, our solution set is going to be 2 and then 8. Oh, that curly bracket notation reads as the solution set is, and then you just insert your proposed solution. In this case, it's 2 and 8. Let me just box that. Now, they want you to check, so let's check to make sure that our absolute value equation holds. So when x equals to 2, I'm going to plug this into the original equation. So that implies that we're going to have 2 times the absolute, 2 minus 5 plus 3. Is it going to equal to 9? That's what you need to be asking. So let's check. 2 times the absolute, 2 minus 5 is negative 3, and then plus 3, and which is 2 times, all right, absolute value of negative 3 is 3, and then plus 3. So 2 times 3, 6 plus 3, which is 9, which checks up with this 9. So 2 is definitely a solution. Now let's check when x equals to 8. So we're going to have 2 times the absolute, 8 minus 5, and then plus 3. Is it really going to equal to 9? Alright, so you're going to have 2 times the absolute, 8 minus 5 is 3, and then plus 3. And the absolute value of 3 is 3, so you're going to have 2 times 3 plus 3, which is 6 plus 3. Again, this is going to equal to 9, so it checks. Alright, so that means that for sure 2 and 8 are the solution to this equation. Alright, next example, so let's look at something like this. Absolute of 3 over 4x minus 7 and plus 10 equals to 4. So let's follow the steps. So first step is what? Isolate the absolute value. So we need to subtract 10 on both sides. Then what we're going to get here is absolute of 3 over 4x minus 7 equals negative 6. Alright, now before you do anything, let's stare at this equation for a little bit. Do you notice something a little bit funky here? Look, we're saying that absolute value of some quantity equals to negative 6. Could that ever happen? Could the absolute value of anything be negative? No. So in this case, do not do any algebra any further. Our answer is going to be no solution because absolute value of some quantity must give us some value that's going to be greater or equal to 0. So in this case, this is impossible. So therefore, no solution. Oops. And the notation is just curly bracket with nothing in it. And I believe that in XYZ, they want you to write this as does not exist, D and E. Same thing. Alright, next theorem is equations with 2 absolute values. So it says that if U and V are an algebraic expressions, then absolute value of U equals to absolute value of V. That implies that U equals to V or U equals to negative V. So basically it's telling you is that if you're going to drop that absolute value on U, then you drop that absolute value on V. And what's our answer? U is going to be plus or minus V. Okay, let's do this example. Solve absolute value of 6x minus 5 equals to absolute of 3x plus 4. So in this case, our U is 6x minus 5. So let me just write that out. So this is going to be U, and then 3x plus 4 is going to be our V. So let's follow the theorem. The theorem says if we're going to drop that absolute value on both, then this implies that U is positive V or U is negative v. So let me write it. So our u is 6x minus 5. So taking the positive side of v, we're going to have 3x plus 4. And then also u equals to negative v. So in this case, our u is 6x minus 5. Now next step, be careful. V is the whole quantity 3x plus 4. So if you're going to take negative v, that means that you're going to have a negative, then parentheses, 3x plus 4. Do you see that? Because this is just our v, and this is our v. So negative v means that that negative is attached to the whole entire quantity of 3x plus 4. Okay, so let's solve these two equations as we normally would. So step number 1, if I want to work on the first equation, I will just subtract 3x from both sides. Then here you're going to get 3x minus 5 equals to 4. Then add 5, then you get 3x equals to 9. Dividing by 3, then we get x equals to 3. Alright, let me just box that. And let's work on the other equation. Okay, now on this side, we're going to have 6x minus 5 equals to, don't forget to distribute the negative to both. So here you're going to have negative 3x and then minus 4. Alright, solving for x, I'm going to add 3x. Then we get, 9x minus 5 equals to minus 4. Adding the 5. Then here what we're going to get is 9x equals to, what is that? Positive 1. And dividing by 9, it looks like our x is going to be 1 over 9. Okay, so let's see if our proposed solutions are correct. So let's check. When x equals to 3, you're going to plug this value into the original equation. So you're going to have to ask yourself, does absolute of 6 times 3 minus 5, does it equal to absolute of 3 times 3 plus 4? That's what you need to be asking. So let's do this. So this is what? 6 times 3, 18 minus 5. Does it equal to 3 times 3 is 9 plus 4? What do you think? I think this is going to be true because here you're going to have absolute of, what the heck is that? 13? Does it equal to absolute of 13? Yes. So it checks. So therefore, for sure, x equals to 3 is a solution. Now let's go with, let's check. I'm running out of room, so let me go over here. Check when x equals to 1 over 9. Don't hate. I know that you probably don't like fractions, but become one with it. Alright, so we're going to have is 6 times 1 over 9 minus 5. Does it really going to equal to absolute of 3 times 1 over 9 plus 4? That's a 9, sorry. Alright, so let's take a look. Okay, let's work on the left-hand side. So here you're going to have 6 over 9 minus 5. But is it okay if I reduce 6 over 9? 3 is going to go into both, so 6 over 9 is going to become 2/3 minus 5 in absolute. Does it really going to equal to the absolute? Now here you're going to have 3 over 9, which is going to be 1/3 plus 4. So let's compute. Oh no, I'm completely running out of room. So I'm going to take this over here. I hope you can follow my work. I'm sorry if this is too messy. So let's work on the absolute of 2/3 minus 5. So here you're going to have absolute of 2 over 3 minus, now we need the common denominator. So in this case, what we need to do is multiply the top and bottom by 3 to 5. So here you're going to have, if you're going to have minus 5, you're going to have to multiply here by 3 and a 3. So this is going to be 2 over 3 minus 15 over 3. So this is absolute of negative 13 over 3, which is positive 13 over 3. Alright, so that's just the left-hand side of it. So the question was, does this equal to, oh my gosh, this is so nasty looking. Sorry, y'all. So here you're going to have, it's going to equal to 1/3 plus 4. So here you're going to have 1/3 plus, now on the 4, you need the common denominator of 3, so you're going to have to multiply here by 3 over 3. So this is absolute of 1/3 plus 12 over 3. So this is absolute of 13 over 3, which is 13 over 3. So they match. Oh my gosh, this is the ugliest work ever. So this was the left-hand side of the absolute value, and this one was the right-hand side of the absolute value. So it checks. So let's write down the answer. So therefore, I'm just going to go over here. Our solution set is 3 and 1 over 9. And there's our answer. Alright, now next theorem is absolute value inequalities with less than or equal to. Alright, so let's take a look at this theorem. So of course u is an algebraic expression, and it says that absolute value of u is less than a. That implies that u is less than a, or u is greater than negative a. Alright, now if you put these two statements together, this means that your u is going to be sandwiched between negative a and a. So either way you want to write this is okay. So let's try to understand what the heck just happened. So given that absolute value of u is less than a, how do you drop that absolute value? When we drop that absolute value, u is going to be less than a, which means that on the positive side of a, your inequality stays the same. Now, if you take the negative side of a, then your inequality sign is going to switch. So here you're going to have, if you drop that absolute value, u is less than a, or u is greater than negative a. Basically means that you sandwich between negative a and a. Now, same thing's going to happen with less than or equal to. So if you have absolute value of u is less than or equal to a. Now, how do I drop that absolute value? Well, our positive side of a is going to have the same inequality. So you're going to have u is less than or equal to a. But when you take the negative side of a, your inequality sign switches, just like that. Here you're going to, so therefore we're going to have u is greater or equal to negative a. So again, putting this all together, you can say that this is negative a less than or equal to u, and then less than or equal to a. Please memorize this property. Okay, so let's look at some examples. I think this is going to be example 4, right? So I'm going to say solve. So let's go nice and easy first. So suppose we have absolute value of x is strictly less than, let's go with 5. All right, so let's take a look at this. So this implies that if you're going to drop that absolute value, you're going to have the positive 5 and the negative 5. So here, on the positive 5, you're going to have x is less than 5. Your inequality sign stays the same. Now, if you take the negative side of 5, which is negative 5, your inequality sign better switch. Okay, so this means that negative 5 is less than x and then less than 5. So if you draw this solutions on the number line, our solution is going to be in between this interval. All the x values are sandwiched between negative 5 and a 5. Now, if you want to write this solution as an interval notation, then our interval notation is going to be open negative 5 to 5 open. So here's our answer. Let's take a look at next example. So let's call this one B. Solve absolute of 4x minus 5 is less than or equal to 3. All right. So now let's write the solutions in interval notation, and let's also graph the solution set for this. So, you guys ready? So we're going to drop that absolute value. So how do we drop it is, Well, 4x minus 5 is going to be less than or equal to positive 3. Now on the positive 3, your inequality signs stay the same. Or 4x minus 5. Now if you take the negative side of 3, your inequality sign is going to switch. Alright, so now let's go from here. So here, let's just work on let me just separate this like this so you can tell which side we're working on. So here, what we're going to get is add 5 on both sides. Okay, then here you get 4x is less than or equal to 8. Now dividing by 4, here you're going to have x is less than or equal to 2. Now let's work on the other inequality. So again, we're going to do the same thing, plus 5, and then here you get 4x is greater or equal to, what is that? Positive 2, dividing by 4. Then our x is going to be greater or equal to 2 over 4 is 1/2. So this is just one way to do it, but if you don't like it to solve it this way, you can also do it this way. So given that absolute of 4x minus 5 is less than or equal to 3, we can use, let me see. Where is it? Yeah, this guy right here. Alright, so here what we're going to get is negative 3 is going to be less than or equal to 4x minus 5 and less than or equal to 3. You can also do it in this way and just solve for x. So here you're going to have plus 5, plus 5, plus 5. Then here you're going to have 2 less than or equal to 4x, and then less than or equal to, what is that, 8. And then dividing by 4, then here what we're going to get is 1/2 less than or equal to x, less than or equal to 2. So it's exactly the same thing that as we separate them and then solve each inequalities. But anyways, let's draw the solution set. So it looks like x is going to be sandwiched between 1/2 and then 2. So let me just go with 1/2, and then here's our 2. So either way you're going to look at it, this is telling you that x is going to be greater or equal to 1/2. And then x better be less than or equal to 2, all at the same time. Okay, so where they overlap is between 1/2 and a 2. So therefore, an interval notation would be 1/2 closed to 2 closed. So this is going to be our answer. Okay, our next theorem is absolute value inequalities with greater or equal to. Alright, so let's take a look. Absolute value of u is greater than a. That implies that either u is greater than a or u is less than negative a. So notice that when you drop that absolute value, then you're going to also have positive side of a and negative side of a. But for the positive side of a, your inequality sign stays the same. But if you take the negative side of a, then your inequality sign switches. Exactly the same thing as the previous one with less than or equal to. Okay, so now let's look at this example. So this is example 6, I think. Alright, solve. Okay, so now let's take a look at something like this. Absolute value of x is going to be greater than, pick any number. Let's go with 3 maybe. Let's go nice and easy. Alright, let's solve that. Okay, now this implies that when you drop that absolute value, you're going to have a positive side of 3 and a negative side of 3. So on the positive side of 3, your inequality sign stays the same. And if you take the negative side, your inequality sign switches. So this is what we're going to get. So we're going to have x is greater than 3 or x is less than negative 3. Alright, so let's draw out the situation and see what's going on. So what's going to be our solution set? So here's our negative 3, here is 3. So x is strictly greater than 3. So that means that we're going to have to be shading this way. all the way up to positive infinity, and then x is less than negative 3. So we're going to have this situation. All right, so this is the graphical solution set. Now, how do I write this in an interval notation is negative infinity to negative 3, and then union, and then 3 to positive infinity. So this is going to be our answer. Okay, now let's call that one A. So let's call this one B. Now let's look at absolute of x minus 7 is going to be greater than 3. All right, increasing the level of difficulty just a tiny bit. All right, so let's drop that absolute value. So if I drop that absolute value, x minus 7, now positive side of 3, your inequality sign stays the same. And the negative side of 3, your inequality sign switches. All right, so we got two inequalities that we need to solve. We got this. So here what we need to do is plus 7 plus 7. Then we're going to have x is greater than 10. Now for the other side, if I add 7 plus 7, then here what we're going to get is x is less than 4. All right, so I think we're good to go. So let's graph this solution set. So if I graph this out, what do we get here? 4. And then the key points are 10. Okay, so x is greater than 10. And then x is less than 4. Okay, so this is the graphical solution set. Now, as an interval notation, we're going to have negative infinity to 4, open, and then union 10 to infinity. So this is going to be our answer in an interval notation. And top is the graphical notation. Okay, let's look at something very similar. So let's go with x minus 7. It's going to be, absolute of x minus 7, is going to be greater than negative 3. All right, now let's take a look at that. Before you do anything, think about it. This is telling us that absolute value of something is always going to be strictly greater than negative 3. Isn't that true no matter what? Because absolute value of any value is always going to be greater or equal to 0. So in this case, do you see that no matter what x values that you're going to plug it in, your answer is always going to be strictly greater than negative 3. So in this case, you don't have to do anything. Your answer is going to be all real numbers. Because look, so if you don't see that, so let's take maybe x equals to negative 100 or something like that. Then here you're going to have absolute of negative 100 and then minus 7, which is absolute of negative 1 over 7, which is just positive 1 over 7. This guy is always going to be greater than negative 3. And if you plug it in, x equals, say, I don't know, maybe, what would you like, 70? So that implies that absolute of 70 minus 7, which is absolute of 63, which is going to give us 63. Well, this is always going to be strictly greater than negative 3. So do you see that no matter what x value that you're going to plug it in, that absolute value is going to be, it's going to give us a positive value no matter what. Now the positive value is always going to be greater than negative number, in particular negative 3. So this is telling you that you can plug it in any value of x and this inequality stays true. So therefore, we say that our answer is all real numbers. Okay, so which means that in an interval notation, let's go with the graphical notation. Here's negative infinity to positive infinity. Now all real number means that it's defined all along that number line. So as an interval notation, we're going to have negative infinity to infinity. And this is going to be our answer. Okay, for our last example, I'm going to mix things up a little bit just to see if you can solve the equation or inequality. So let's take a look at A. Negative 3 times the absolute of x minus 4, and then plus 4 equals to negative 5. All right, pause the video and try to do this on your own. All right. but I'm just going to keep going here. So here, first you need to isolate that absolute value. So I'm going to subtract 4. Then we get negative 3 times the absolute of x minus 4 equals to negative 9. Now we need to isolate that absolute value. Then I'm going to have to divide here by negative 3. Then we're going to have absolute of x minus 4 equals to positive 3. Alright, so now if you drop that absolute value, we're going to have a positive side of 3 and a negative side of 3. So here you're going to have x minus 4 equals to 3, and or I should say, and then x minus 4 equals to negative 3. Solving this separately, plus 4, then here you're going to have x equals to 7, or let's do the same thing, plus 4, then here what we're going to get is x equals to 1. So therefore, our solution set is 7 and 1. And also you can check these solutions and it should satisfy the equation. Alright, so now let's go with part B. Alright, so part B is absolute of 6 minus x equals to absolute of 3 minus 2x. Now let me just write down that property that we have to know. Absolute value of u equals to absolute value of b. This implies that u is plus or minus b. Alright, so now maybe I should have wrote this out too. So absolute value of u equals to a. That implies that u is plus or minus a. Okay, so now let's apply that property. Then we're going to have 6 minus x equals to the positive side of v, which is 3 minus 2x. That's a minus sign. Or you're going to have 6 minus x equals the negative v. But be careful, negative is going to apply to the whole quantity 3 minus 2x. So be careful on that step. That's a common mistake that students make, is right there. Alright, now let's solve the equation on the left hand side. So here, what should we do? Maybe add 2x I should say, sorry. So here you're going to have 6, and then what? You have 2x minus x, that's 1x, equals 3. Subtracting 6. Then here you're going to have x equals to negative 3. Alright, let me just box that. Okay, so now let's go with the right hand side of the equation. You're going to have 6 minus x equals negative 3 plus 2x. Alright, so then what should we do? Minus 2x, then here you're going to have 6 minus 3x equals to negative 3. And let's subtract 6. Then here you're going to have negative 3x equals to negative 9. Oops. And dividing by negative 3. It looks like we're going to have x is going to be positive 3. So it looks like our solution set is going to be negative 3 and a 3. Okay, make sure to check your proposed solution, but I already checked it ahead of time and this works. Alright, now let's look at the next one. We got absolute of 2x plus 3 plus 5 is less than 4. Alright, please pause the video and try this on your own. But I'm going to keep going. So here, first I need to isolate that absolute value. That means I need to subtract 5 on both sides. Then here you're going to get 2x plus 3 in the absolute is less than negative 1. Now, did you try to solve this absolute value inequality? Well, you shouldn't, because look, we have the absolute value of something is going to be less than negative 1. So, can the absolute value ever give you a negative? No. So in this case, this is impossible because we're telling us that absolute value of any number, which should be positive, is less than negative 1. So in this case, our answer is no solution, which is curly bracket with nothing in it, or does not exist is just fine too, D and E. Alright, so let's take a look at another one. Part D, absolute of 3x minus 3 is less than or equal to 6. Alright, so first we need to drop that absolute value. Now there are a couple ways that you can do. You can automatically sandwich 3x minus 3 by negative 6 and 6 if you like. But let me just write down the property. If you have absolute value of u is less than or equal to a, that means that either u is less than or equal to positive a and u is greater or equal to negative a. In which case, this means that negative a less than or equal to u less than or equal to a. Okay, so I don't care which one that you want to use, but let me use this guy right here on the bottom one. So here, our a is 6 and u is 3x minus 3. So if you're going to drop that absolute value, you're going to get negative 6 less than or equal to 3x minus 3 and then less than or equal to 6. Okay, so now how do I solve for x? I need to get rid of this 3. So plus 3 plus 3 plus 3. Then here you're going to have negative 3 less than or equal to 3x and then less than or equal to 9. Dividing by 3. It looks like what we're going to get is negative 1 less than or equal to x and then less than or equal to 3. Alright, so graphical solution set is going to be, here is our negative 1 and here is our 3. X is sandwiched between negative 1 and 3, so our solution set is going to be in here. So as an interval notation, our solution set is negative 1, comma, 3, and they'll both be closed intervals. And there we go. Alright, let's make this one as the last example. So we have absolute of 3x minus 4 is greater or equal to 2. Okay, so let's drop that absolute value. So if we do that, then we're going to have 3x minus 4. Now we're going to get positive side of 2 and negative side of 2. But the positive side, your inequality sign stays. And for the negative side of 2, your inequality sign switches. So let's solve these two. I'm going to add 4. Here you get 3x is greater or equal to 6. Dividing by 3. Then you're going to have x is greater or equal to 2. And let's see, on the right hand side, we're going to have plus 4 plus 4. Then we get 3x is less than or equal to 2, is that right? So, and then dividing by 3, we're going to have x is less than or equal to 2/3. Oh, I think I forgot to write down the property that we're using, so let me just write that on top. So if you're given absolute value of u is greater or equal to a, when you drop that absolute value, then you're going to have u is greater or equal to a, or u is less than or equal to negative a. That's the property that we just used. So let's graph this solution set. 2/3 is less than 2, so okay. So let me see. So we got x is greater or equal to 2. And then x is less than or equal to 2/3. Alright, so we're going to have, as an interval notation, negative infinity to 2/3 and then union. Oops, 2/3 is included, so this should be a closed bracket. And then closed to positive infinity. So this is it. How you guys all doing? Practice makes perfect, so make sure to do your homework. And if you have any questions, please let me know. And once again, great job, everyone.